Alright, here we are again. Another holiday video. So I can only get halfway through it before I just, no, can't listen to this twice. He's just too annoying. How he put things. They're horrible paraphrases, and yeah, there's just no, yeah, I just play it.
DraftScience. I don't think I'd be the kind of person to make videos to a person I hate. I try not to hate anybody.
Right, so I shouldn't have said the word hate. I was just using it as a placeholder probably for some other word that has to do with degrade or insult or disrespect. Yeah, that's probably the key word. Just a level of disrespect that is just reeks, it just permeates the environment, that you could call it a kind of hate because there's so little respect. Okay, so that's probably what I should have attempted to convey. Clearly, like I said, your hypocrisy is so over the top that it can only be called duplicity, and your double standards. I mean, again, conventional physics provides no detail. They're obligated to provide none. Their models don't have to have any consistency. They can have these preposterous imbalances and incompatibilities in them. They make these assertive statements, sort of like Einstein saying all acceleration is the same, or some kind of declaration that's way beyond the bounds of his capacity to make such a declaration, to compile evidence for such a declaration. That somehow we could never know who's moving and who's not because he just said it, based on the fact that, yes, from our limited knowledge perspective, that's true, but maybe if we have a little bit more knowledge, we'll be able to see right into the kernel of your momentum and see exactly what your momentum is. That these will all be a measurable quality that we all have. How did he know? Well, of course he didn't know. And physics is just full of those declarations. It's a wave, it's this, it's that. De Broglie declarations about what electrons are. Just declarations. We don't need any evidence. The whole Huygens contrivance. Dark matter, again, just obvious. And you just keep justifying, defending these preposterously weak explanations of function, the huge inconsistencies, and then you're nitpicking me for a kind of minutia in detail where I can't get away with saying, well, look, just can't we agree that, okay, you could do this idea of pressurizing an atom, the force went in, it changed it, it's now a filter, it's now doing something differently, and you can't take anything as a loose concept. You want to know where every rower is, and again, it's obvious you're not expecting that from anybody else. And so, what is that but some sort of diss? Like, I can't be trusted to have accounted for anything, and I'm somehow up to something, or I'm going to somehow try to cheat the argument. When no, I'm just trying to have it in some sort of terms where everything doesn't have to become preposterously technical as an argument. You don't have to add all the details for every single case. You can make some assumptions, and again, I was making the assumptions you sort of understood this conservation of momentum idea, and that the force that's really acting in all these things are the hidden forces, like in the case of the floating puck, super cooled. As I pointed out, the only force we really know that's in the equation is gravity. So we know that whatever's happening, it has to happen through that force, and it can be accounted for by understanding that the thing becomes, like I said, a mirror, and now like a magnet, it's doing the same thing as a magnet. It's going to, segregate force, change it, so it's going to go from emitting a blue force to emitting a red force. Now, there's no conservation problem. It's emitting the same amount of momentum. It's just emitting momentum that the other guy is going to feel more. And so I said, well, yeah, this guy can figure this stuff out. I don't have to be, you know, I don't have to go over it every single time, do I? And basically now you're saying, yes, I do. And, you know, that's kind of garbage. But anyway, yeah, so I'm just saying, I said it. You know, if the same theory was proposed by somebody else, I don't believe you'd be demanding this minutia. So if it came from conventional physics, if some college or some other institution had declared, we think we have found it, I don't think you would be this rigorous in making these arguments for the minutia. And I'm just saying that's a sign of disrespect, clearly. They have credibility because they did a lot of math. And you sort of have to believe that that's really all a physics education is, right? 90% of it is just doing formulas. I mean, I've sort of found that just by watching the lectures, right? I mean, 90% of the content, in some cases 99% of the content, is just memorizing formulas. It really has nothing to do with understanding any conceptual ideas at all. I mean, almost zero content has anything to do with concept.
Who was it who said, "Let no man drag me so low as to make me hate him"?
So again, I didn't want the focus to be that word. I wanted the focus to be your hypocrisy. So, but whatever. I mean, just again, with the stuff you let them get away with. Again, so he's you know, he's going to talk about Stern Gerlach again. Now, they've never proven the existence of these quantum qualities. They added two properties to things, spin and quantum number. Just invented crap. Okay, there's no evidence that these things actually exist as real properties of something, and that they would have anything to do with what they've called them, like spin. They're just mathematical notions, not conceptual notions, not functional notions, and they're bred out of a complete misunderstanding of how reality works. So again, I could go back to the argument about gravity. You know, it's not something that was apparent to me either. I mean, I never thought about it for my first 40 whatever years on this earth, that I could possibly be bouncing in the gravity, you know, that I'm actually, that my junk, okay, is actually, some of it's moving up, some of it's moving down, some of it, all the time, it's got to interpret the motion. The force is actually pushing me down, and the earth is actually pushing me up, and those are real events. I never really thought about it. I didn't really get it. So maybe none of the other physics people ever really thought about it and thought, well, what's the consequence of that if I'm going up and down and then I move in a direction? Well, doesn't that create an at least line, a much longer line that I'm traveling? I'm not traveling this nice little straight line anymore. I'm traveling this, you know, my junk is doing this. Alright, so its velocity is much, much higher than this apparent velocity. I never thought of that. Maybe none of them thought of it. But once you understand that concept, then you say, oh, well, that's the property. I'm giving the thing a property that, no, the property is a consequence of its environment. It's a consequence of other things that are happening. And that's what I've sort of pointed out with Einstein's busting of rational physics with his stupid bent space. He took energy out of the universe. He just eradicated a big pile of energy, the energy moving the earth into the sun, the energy moving planets around, and he destroyed it as energy. And my point is if you followed where that energy would have gone, or what it could be creating, well, then you can understand why the planets are under pressure, and why they're hot, and the melting inside, why the earth is melting inside. Well, why is it doing that? Oh, because it is in gravity. A real force is affecting it. And then when you sit there and take it one more step, you can say, well, where's this energy come from magnetism? You say, well, what if the magnet is just filtering the energy that's already here from the gravity? And it all falls into place. And the fact that you don't see how that is a huge, I mean, that is just the black glass breaking right before your eyes. And okay, you're not seeing it that way, but I mean, when I saw that happen, when I watched that happen to my simple, particle gravity makes so much sense, because it just perfectly does this push thing together thing so well. And then I realized that this is the force. This is the force. This is all the other crap is just this crap. And yeah, then that was just like, boom, I see it all now. Everything can be explained. And so the competition is between that and these silly notions of spin and quantum numbers and crap. The things they have to invent because they're realizing there's too much energy in the system. We have to account for it. So we have to make up some kind of spin crap or some other kind of energy source because there's too much energy. Because they destroyed it by creating a fake source of gravity.
I am up to speed with your explanations about rovers getting in. I note in one of your...
Well, in a way you're not, because I still don't think you're seeing. The first thing you always have to do is remember that if I'm going to talk about this interaction, I have to always remember that these two things are in this gravity field. I always have to remember that they're always got stuff coming into them and they are radiating. They are at an equilibrium with that radiation if they're not doing anything obvious, like if I don't let them go. But that force is real. And so you always have to think first, okay, just as the ground condition for everything, there's no such thing as a quiet place for something. Nothing can go to the universe, to the really dark place, and say, I just want to sit in a quiet place and be left alone. There's no such place. So wherever this goes, it's going to be, there's a ton of rowers jumping in the boat all the time, just in the nothing state. And then when I add some new rowers, I have to always remember the new rowers are in the environment of the existing rowers. And some of them aren't going to be new rowers. They're just going to be not blue rowers, but red rowers. So I don't think you quite got that yet.
Your explanations, I'm sure this was the case when you talk about particle interactions, the fundamental particle interactions, you say a blue...
So he says he's sure that this is the case, and then he says, well, maybe it's not the case. Yeah, look, yes. I'll go over at the end of this video. I will once again attempt to make a declaration about what I think it is. Like I said, I didn't want to be too explicit. I just want to get the concept understood, that conceptually, theoretically, this has merit. I don't know if I want to get into some conversation about whether it's a three-dimensional thing or a two-dimensional thing, or whether it's this or whether it's, whether I need to get that explicit. I just want to say proof of concept. But whatever. If I have to go further than that, okay, I'll go further than that. I don't see why it would be necessary, because I think I have proven the concept.
Blue goes in, but a red comes out. And in the case of quantum locking, you're now talking about blue being reflected. That's a source of confusion.
Well, it shouldn't be. I mean, I've been talking about the reflection thing for months now. As the key ingredient to what makes the whole thing work is the fact that you're letting energy remain in the system. You're trapping it, and that's how you're trapping it, is by mirroring. So anything that's excreting a force, if something's excreting more red than blue, it means it's also reflecting more red than blue. So what it excretes is what it reflects off of. So it's always a mirror that is pushing stuff through, that's coming through the mirror, is the concept. But I didn't want to get into this energy thing again, where people get lost in that. But that's the function of magnets. They're not generating the energy. They're converting the energy. So the energy that's coming out of the mirror didn't come from the atoms of the mirror. It came from the universe.
Maybe I'm mistaken. Maybe I remembered it wrong.
Yes, well, it is a little bit drafty. So yes, you could. I haven't explained it or detailed it perfectly the same every time, in the sense of the reflective argument I'm certain of. The perpendicular argument is more complex. And as I've pointed out, in systems, I think it's clear that it's not random which way is the perpendicular direction. It has a bias depending on the history of the moving object. So depending on what it was doing, whether it just turned left or whether it just turned right, a couple of swimmers ago, a couple of rowers ago, is going to make a difference on whether it's more likely in the future to turn right or to turn left.
But as to the Stern-Gerlach experiment, when I said your explanation appears to only account for the mere spreading of the beam,
which again, it just had nothing to do with what I explained, so I'm just saying I don't think it was a fair way to say it only accounts for that's what I described. That's not what I described, and I think my description was sufficient, where you'd have to be deliberately trying to pervert it into something else to make it sound like I said something else, but I clearly didn't say that. I clearly didn't indicate it does that, and I didn't clearly cite any reason why I should believe it does that. So, sorry, I don't buy this argument that you made a perfectly reasonable error. No, you made something less than reasonable as an error.
it would be true that it accounts for, well, it would seem to be true, it would account for the splitting of the beam if silver particles in the
So again, you were using the word particle. It's a little too ambiguous. Okay, an atom isn't a molecule, right? It's not a brick. You can't call everything a particle. Each one has its own properties, and atoms have symmetry. Elemental atoms have symmetry. There's not, they're not deformed. They're not barbells. They're not, well, they could be a barbell, I suppose. They could have some eccentricity in their dimensional shape, but generally speaking, one would have to say the atom is incapable of being, it is a nuclear object, and it has to have symmetry to the nucleus. So the atom is not a pointy thing, and if it has any native polarization, its native polarization is not going to be in some pointy form, I guess I would argue. It's going to just be in a dimensional form. Like I might argue that a hydrogen atom, unlike the rest of the atoms, is a two-dimensional atom. It doesn't really work in 3 dimensions. It's flat.
well, the thing is they're neutral, so they're not like magnets, but in a sense, there are.
No, see, you've gotten it all wrong. This has nothing to do with dipole. So this is again where I've tried to explain. I know you're stuck with what they tell you in these stories, and they say there's no such thing as magnetic monopoles. No, I'm arguing there are. Okay, not only in the form of electrons and protons, but the atom itself can be a monopole. It can be inflated, so to speak, or deflated a little bit, and go from red to blue in terms of its overall excretion. It's more reflective to one than it's reflective to the other. So it never goes all blue or all red. It just becomes more red or more blue. But it's clearly not a dipole in that circumstance. It's a monopole. It's charged.
Well, that is the theory. Is there because of the two? However, doesn't matter. The point is there pointy? Yeah.
Okay, the point is they're pointy. So maybe I'll just draw from there because that's a statement. Okay, he's made a statement. I don't know why I have to go all the way around. It doesn't go left to right as well as it goes right to left. But anyway, all right. So Stern-Gerlach is basically arguing that the atoms are ejected from a system. I drew them as little atoms. They're atoms. All right, and the idea is they're heading in this direction, and the argument is as they're heading in that direction, they're going to do a thing where they're going to, like a ping pong ball in between charged plates, they're going to pick up a charge and become repulsive. Then they're going to move the opposite way. Their charge is going to go opposite, and they're going to end up doing this through the device. And when the device ends, there's no choice. They're either going up or they're going down as they come out of the device. There just really isn't any other way for them to come out of the device except for pretty much up and down. Heading up and heading down. So if it was a ping pong ball, you could just follow the ping pong ball and kind of understand, yes, from any point it leaves the device, it has to have a trajectory that has some component in the vertical directions. Just has to. It can't do this straight across thing anymore because it's doing this to get across the device. Alright, so now he's asserting that this atom has some kind of shape coming into the device that I never stated existed, or that it's some shape like a triangle and somehow it only does this stuff on one side and it's somehow can't do this thing. When no, the atom is going to go through the device, and what it's basically going to do is it's going to become reflective to blue energy when it's high, and it's going to become reflective to red energy when it's low. So you can think of that as a little bigger and a little smaller. It just doesn't really matter. It's going to change its polarization, its charge, from a positive monopole to a negative monopole. And that's what's going to cause it to bounce off of the red side, bounce off the blue side, is the fact that as it moves towards it, it becomes it. And it's essentially, you know, in some sense, when you're using these single atoms, you're almost getting back to the superconductivity argument, that as single atoms you've probably eliminated heat and noise, and so they're probably very perfect in terms of how well they reflect the environment, because there's not heat noise screwing up their polarity, you know, making them too big or making them too small in the wrong locations, changing them. Like I say, when one's losing its blueness, okay, over here, if it got hit with a bunch of heat energy, that could pump up its blueness here, and it could end up not, you know, charging red. It could take it longer, so you could have all kinds of differences in drift and all kinds of stuff like that. So this is sort of another way of looking at superconductivity, is to work with single atoms in an unpressurized system, because you could argue that those single atoms in an unpressurized system aren't being jerked around by a bunch of heat that keeps messing up their polarity, their pressurized condition, their voltage. Yeah, it's one way to say it, I think. So again, there's no shape. I'm clearly arguing that the difference is kind of in this idea of the depth of the distance between the electrons and the protons, and I don't care which way it works. I'm just arguing that as you change that distance by adding more pressure between the electrons, then you change the polarity. So even though the electrons are still on the outside, this is the negative condition, or we'll say positive, because the proton is now stronger because the electrons are weaker from a distance. If a viewer observing these things from a a location would see this one as more negative, and it would see this one as more positive from a distance. That's the fact. Because the electron is further away from the proton. So its charge potential is stronger. Alright. I think shouldn't have to go into too much detail on that.
And can be regarded as in some way pointer.
No points.
And especially in your theory.
No.
So if it came through like this or like this,
no,
at a fairly consistent speed,
no,
yes,
no. So again, it's an atom. The argument isn't that it's got a shape, and even if it was a clump of atoms, okay, its shape would still mean that it's going to polarize as a charge, a single charge. It's not going to become a dipole. It's going to become a charged monopole. The atom is going to become a monopole of charge. There won't be any other side to its magnet. Now, in a substance, there might be some of that because, you know, it could charge on one surface, the surface facing the external world, and who cares what the back end is doing? Okay.
At least pure Leasing argument would hold. But presumably, if it came in like this, there would be somewhat or exactly like this. There would be an almost tendency to actually pass all the way through, and to varying degrees would change the angle because of the exposure.
Again, this bullshit argument. I've never made any arguments about how you could scrape up the surface of steel or metal and change its permittivity or change Lenz's law. Lenz's law has to be changed by, well, let's see, I don't even want to get into cutting grooves and stuff and explaining all of that crap. But clearly you're aware of those things, and so that just has to do with how well it's able to transmit, get rid of the pressure. It has to get rid of the pressure. The fat atoms have to give the fatness to the small atoms. Okay, and if they can't do that, what's the right term to use? Again, it's maintaining its magnetism is the thing it's doing is constantly reacting. That is, going from positive to negative to find a balance between the force that's coming at it. And once it's that, again, see, you always have to think in terms of the fact that everything, this movement thing is so important. As soon as something moves forward, that creates more pressure. The reaction is to create more reflection. The reflection is reflected back, but it's also becoming a magnet, a piece of charge. That means it's going to actually let more red stuff through also. Well, that's the wrong way to say it. I mean, the overall substances, but yeah, I know. Let's just stick with the reflection, because the reflection is perfectly consistent with the idea of mirroring gravity in the perfect Lenz's law circumstance of the superconductor. So again, I'll just restate that the reason why it works is because there's no heat messing up the reaction, in taking away 5% of the energy here and taking away 5% there. So without those losses, the system doesn't fail to balance, it balances. So it's like tipping a boat. To go back to a boat analogy, there's a certain amount of tipping, the boat capsizes. It can't take it. It breaks the system. So it doesn't take much noise in this system for you to break the balance, and therefore the system collapses as having a capacity to levitate something. The levitation won't work because the balance isn't perfect.
So that's the gap in the explanation. And furthermore,
so okay, so he's you know, this and this kind of rhetoric, you're saying you can't understand how that might piss me the fuck off. Like somehow my explanation had a gap in it. No, you just made up a whole bunch of premises that I didn't have to account for. You had never showed me those in advance and told me, oh yeah, well, silver atoms are pointy, you know. Well, no, I didn't know that. You know, so why should I account for something I didn't know existed? And so again, he's trying to paint it as if I made some catastrophic error because I didn't know he had notions in his head that are just wrong.
I reiterate on the quantum blocking.
So he's reiterating things, you know. Again, go ahead and reiterate, but unless you counter argue, your reiteration isn't going to mean much, because I've dealt with your iteration.
I don't see, without a video explaining Lens law in terms of rowers, because rowing exchange of force bits seems to be.
Again, this just goes back to what I said originally. So again, maybe he's okay. Maybe he's already accepted, because I already explained that you have to always remember gravity. You always have to remember there's a force coming at everything, and you're going to basically reflect half of that force, whether it's red or blue. So at one moment, you're like a chameleon. You could be reflecting all the blue stuff. The next moment, you could be reflecting red. And that, okay, accounts for the momentum difference, because if I'm reflecting red, okay, and you're blue, the red's just going to seep right through you and leak out. It's not going to have an effect on you. I can only affect you if I'm reflecting blue, if you're blue.
The principal explanation for it all, or is hoped to be, then without an explanation of Lens law in terms of exchange of rowers that is consistent with the gravity mechanisms and the polarized attractive and repulsive mechanisms that you use.
So again, I can't help that you haven't understood a damn thing I've been saying for 7 years, or you know, at least the last year. So what can I do? You know, I mean, you're saying somehow I didn't explain it. No, I explained it. I'm telling you, it changes the surface of the material. It biases it, so it becomes more red or more blue. It becomes charged, and the whole function of charge, the reason why two charges push away from each other, is because of the trapped ping pong balls. So I've already accounted for this. So to tell me you're not accounting for the rowers, you're not accounting, well, of course I am. I'm telling you how it works. The ping pong paddle changes color, so to speak. I don't know, what can I say to you? If you're not willing to understand the force as having two functional elements to it, blue and red, plus and minus, whatever, and understand that I don't have to account where new balls come from. All I have to account for is the power they have against something that is one color. If I'm shooting one color, a different color at them, or a different color mix, and that color mix is all that matters. There's dummy bullets and real bullets for everybody. There's Krypton bullet, and, you know, everybody's like Superman, all right? And you're either affected by the Krypton bullets and you don't care about the lead ones, or vice versa. You're killed by lead ones and you don't care about the Krypton. And all you're doing is we're all kind of changing our reflectivity to bounce Krypton or to bounce lead, depending on who we're facing, what's coming at us. And so for certain metals, clearly what hits them changes them. So if a Krypton bullet hits them, they become Krypton there, and now they're going to reflect the next Krypton bullet that hits there.
Discuss. You don't get to use that principle. So that principle of Lens's law has to be a whole video, I imagine, on Lens's law. Or
yeah, okay. I mean, Lens's law is a little complicated, because obviously I don't think it's a law. I don't think the way they understand it is correct. Okay, so it's like saying I have to accept their model of a magnet with the swirly bits. I'm not denying the field lines are a consequence. I'm just saying that what's happening in Lens law is that atoms are becoming voltage, all right? Plus and minus voltage, in a sense. That's the current. But the current isn't circulating inside of the substance. It's just being exchanged. The atoms exchange a difference in pressure. and that's all they can do. And they have to exchange the pressure to change what color they are. And if they're interacting with something that is also changing its color, if they want to reflect, they have to reflect the energy at a time that's going to make it when they're the right color. You have to be blue for my blue reflection to affect you. So that's where it gets a little complicated. That's where frequency gets into this thing, and resonance and all these other complex ideas. But I mean, it's not the proof of concept. Again, is all I should have to persuade you of, that this concept has a lot more viability than their vacuous virtual photon nonsense that explains absolutely nothing. And even their lens law that says almost zero about what the process is. So again, you're not asking them to explain any of this, and you're wanting to find detail from me. You don't see the hypocrisy in that.
Go through it briefly before the explanation, but I suspect that it's probably worthy of a whole video, where the prediction of lens law arises from your theory model.
Well, again, I wouldn't even use the word prediction, because obviously we know it exists as a phenomenon, so why would I bother creating canardery to explain it in that way? But yes, obviously I've already pointed out how the mechanism works, and that what's missing from their theory is some understanding that at the nuclear level there are monopoles. Even at the atomic level there are monopoles of magnetism.
So that's about all I can say, really. Very short video.
So again, this isn't reasonably called nitpicking, naysaying, you know, just an endless pile of crap of, but then there's but you know, this could just go on forever and ever, right? Until I give you the videotape, because you won't be persuaded by anything less than a minutia detailed explanation of every single elemental force bit and every single atom and how they interacted. I mean, and again, they don't even have a concept. You know, again, you're asking for me to tell you what color the rowers in the boat, what color shirt they're wearing. They don't have an ocean, they don't have a boat, they don't have rowers, and you're not complaining. You're not talking about how the hell they get away with that raggy shit theory. They got no ocean, no boats, no shirts, you know, no oars. They got nothing, and it's okay with you. Sorry. How can I see that as anything else but just insane hypocrisy? You wouldn't treat them like you're treating me. Obviously, you don't treat them the way you're treating me.
If you do as I ask, that's what I feel is required to move on through the steps of explaining phenomena. Every phenomena, it seems to me, has to be explained in terms of
again, all I'm doing is saying, as a proof of concept, I have a better concept than their concept. I'm doing theoretical physics and kind of pointing out my theory, nails it. Their theory nails nothing. I've given you a ton of detail, a ton of mechanism. They got nothing. Invisible man, invisible space, invisible dark matter, invisible Huygenses, invisible this, invisible that. It's all invisible. It's all nothing, nothing, nothing. Not a single pen to paper diagram of any of it. And you're not a hypocrite. Okay.
Rowers exchanging seats, and as I've said at this juncture, like Feynman asks us to not be how the matter, you know, in his hypothetical story where he imagines the Mayans who just have some new silly arbitrary numerical calculation to predict eclipses. You know, the young upstart comes and says he's no ability to make any calculations, but he says, you know, maybe the sun's the center of it all. I've got this idea. and he's dismissed because he can't make the calculations. I don't want to be over dismissive because of certain details being missing, and that's why I have.
Well, again, the details aren't missing. Again, I'm not attacking mathematics. I'm attacking the concepts that they say are behind the mathematics. Again, there's no Huygens formula anywhere. I mean, none of there's no virtual photon in a formula somewhere. Show me the virtual photon in the formula. They don't call it what it is. So let's not pretend we're arguing about mathematics, because this isn't about mathematics. It's about causes, and causes aren't math. They're concepts. I mean, again, the whole point is their concepts are wrong. Again, the concept of understanding that gravity is bouncing somebody, that's a concept, and it's so freaking important to understand that that's happening. That's actually the real path my atoms are taking. They're not taking what it seems like. What it seems like isn't what it is like. And they have the is like part completely wrong.
Some latitude on the difficult problem of drag, and would make other allowances if it didn't stretch credulity that
it didn't stretch credulity. Again, claiming that in this circumstance, again, what is that? So again, they're not stretching credulity. They have the wrong shaped lens to create lensing. Their interferometer can't possibly work as the beam splitter can't work as described. They can't tell you which is, the photons are interfering with each other, they interfere with this. They're not stretching credulity anywhere. I mean, amazing. Just an amazing statement to say I've stretched credulity because I've attempted to explain to you that if I have a boat, all right, and we're doing these momentum exchanges, that there could be a circumstance where a guy jumps in the boat, does an exchange inside the boat, all right, that leads to actually the guy jumping back out of the boat the same way he went in. Well, no, the way he was going. So somebody actually jumps out of the boat that way. And there's really no momentum change. And all that changed is the shirt colors of two rowers in the boat changed. Again, proof of concept is all I'm after here. All I have to explain is how the red thing hits the object, jumps into the boat, and somehow doesn't become momentum. And I'm saying it can happen if he makes an exchange inside the boat.
Be solved at a later date. Yeah, if you could, it's fine to pause and say, "Well, I'll make this hypothesis." That's like Einstein saying, "Well, I'll just make a hypothesis that fundamentally there is no rest frame, or fundamentally acceleration due to gravity is exactly the same as acceleration due to a force." The equivalence principle, he calls it, or something like that.
Yeah, well, that one's not disputable, right? But it's when he says you can't detect it, that's when he goes off the rails. That's when he starts deciding he's, got some magic powers.
Yeah, it's fine to say the basis upon which you're working upon, and not have calculations to justify that. Other than that, you think it's a principle that best works.
So again, he's always going to resort to this. Always going to resort to this. Again, again, not understanding that every single formula that exists never predicted a damn thing. They're just something cobbled together to describe effects we see. The formulas are a reflection of the effect, not the other way around. The formula doesn't predict the effect. The formula is completely constructed to describe the effect. But they keep thinking math is doing something much more brilliant than that. I guess that's their little fantasy.
Out and fits in a larger schema. That's all fine. But what I think the case of Lenz's law demands at least some attachment to your existing theory, if not entirely grounded in terms of rowers exchanging boats, so to speak, places.
So again, they have nothing, and like I said, again, some of these concepts you have to be very careful of what you say. and it has to be, it's a little bit, there's a little bit of nuance to it, and I don't want to mix it up. I don't want to mix a bad batch. So I'm just giving you the idea, though. The idea is that you can impose upon an atom a change in its voltage, okay, by hitting it with a force. So it matters if the magnet's moving towards it, and if this is happening, that's going to charge up things. Or that's going to make them shift from red to blue. It's going to, and that's perfectly consistent. You can sort of understand. Okay, that's Lenz's law. Okay, atoms that can be puffed up by the force that hits them, they can change their charge. Well, there you got Lenz's law. What more do you need?
So yeah, that's all I can say in reply to your explanations of quantum lock-in and the Stern-Gerlach experiment.
Yeah, it is kind of interesting that the two of them, the one
I don't
explains
hate
the other.
DraftScience.
The one, I guess that was the end of the video. Kind of a weird ending.
The Stern-Gerlach experiment.
All right. But isn't that sort of interesting, right? I mean, who would have thought that somebody would have mashed those two things together, right? And I did it right in front of you, right? I didn't do it in some magical way. I didn't go read a bunch of books to go cobble those two things together. But it is funny how the two of them are the same effect. I mean, that you can rationally understand that the same mechanism is causing both effects, and in a sense, both of them are doing it in this perfect kind of way, because they're not stuck in a metal that has temperature. They're not in a noisy environment. In spite of the atoms being ejected by heat, once they're ejected, again, they're not in the pressure anymore, right? They're being liberated from being under pressure, and pressure is part of what makes heat matter. Heat can't make much difference if you have no pressure to obligate things to keep getting hit by the heat. That kind of thing. So once the atoms are free, we might think about them as being little molten blobs of silver, but no, the atoms themselves aren't molten. The molten effect only happens when they're not right next to each other and trapped in a circumstance where the heat can't get out. That's when they're red and liquidy and all that stuff. But these little free atoms, would be very much like a superconductor in the sense that they're not in a hostile environment. They're not in an agitated state. An agitated environment anyway. A very agitated. Not nearly as agitated as they were when they left. Let's put it that way. They're only a few thousand degrees cooler. You get cold very fast when you move away from something. So as you go into space, it gets colder and colder. It can get really cold out there, and that's where they're kind of going, out into space. But anyway, the fact that they would react, and like I said, the fact that I made it kind of understandable that what is superconductivity doing? It's increasing reactivity speed, because you don't have any of this lag. There's no lag, so things happen not instantaneously, but as fast as they can possibly happen. So there's a pure action reaction is as clean as it can get in physics in the super cooled environment. The action reaction gets faster. So even though we think of it as slowing things down, no, it's making action and reaction perfect as fast as it gets. Let's just put it that way. Alright, so that'll have to do. Oh, okay, so you did mention so I'll try to explain the pressure relieving element, the element that doesn't cause an exchange in momentum in the boat. Alright, so here we have the boat, and it's a blue boat, so there's only blue players in the boat. No red players are actually in the boat. So what's going to happen though is a red is going to interact with a blue player, which it can do, but it can only do it under this circumstance. And so there's going to be a tendency for the blue to jump out and the red to stay in. Well, the red can't stay in because it's the wrong color, so it's not going to do that. And so what's going to happen is there needs to be another interaction. So let's say the red goes in. Now we owe the world a blue out, okay, but we're not going to give you the blue out yet. So before you get your blue out, before you get your secondary interaction, your blue interaction, we're going to have another interaction with another red coming from another direction. So now a red coming from this direction is now going to interact with another blue, you could even argue, okay, coming from a different direction. And then what really is going to happen is the two blues, instead of this blue popping out, these two blues will just exchange their seats. Alright, and what you'll really end up doing is taking this red that went in, and you'll have two new reds going out this way and this way. So they're coming in this way and this way, and what they're going to do is come out this way, alright, and this way. And well, that's probably the wrong way to say it again. Sorry, I got too much. It ends up being. I'd have to do it one more time. One more time. Two interactions. See, this would work better if the two reds come out this way. Okay, because then you change things. And that's what you really need to do, is change something. But the real point that I'm trying to get to is that the interaction doesn't change the momentum of the boat. The boat doesn't keep any of the red that came in. So maybe just keep it simple. So maybe it's only 1.5 interactions. So the real argument's going to be is that there's a red comes into the blue allows for there to be a interaction between another red. Alright. Let's just keep thinking here. See, I need the blue for there to be a blue-red interaction, because there has to be no, it really doesn't have to be. So the red comes in. Alright, let me pause. And I'll do some drawing, and then maybe not be confusing myself. Alright, I think I got it. It's not as complicated as I thought. Oh, I didn't have the drawing on. Sorry. Shit. Crap. Fuck. Shit. Dumbass. Alright, so this is what I drew before, which was wrong. So that's a good thing I didn't have the drawing on. Sorry for the extra bit that's just wrong. So, alright, so what's really going to happen is a free red, okay, so a red coming at this thing from whatever source is going to hit a free blue, okay? It's a blue that wants to get into the boat, but it's technically not going to happen. So the boat won't get this piece of momentum from this direction. Because what's going to happen is the red and this blue are going to hit each other here, and they're going to exchange their momentums inside the boat. And so what's going to leave the boat is the red is going to leave this way, perpendicular, and this blue is going to leave this way. That never hit the boat. So no momentum changes in the boat. All you're doing is changing the momentum of these two objects. And so technically it really wouldn't matter if I made this a red instead of a blue, because all I really have to do, well, it would matter, because then you're back to this red going straight through, which is fine, really. The only thing you don't want the red to do is go back this way, so you're just trying to stop the reflection. So either one of these stops the reflection. But see, yes, you also want to stop the red from going through, because there's no evidence that it goes straight through. So it's not like the magnetic energy goes straight through the magnet. It's clearly diverted in the magnet. So when the red energy hits the blue section of the magnet, it's getting diverted to come out of the red end. Yes, so you can't go straight through, because then you would have a disproportionate force remainder that would be a problem. So so it's got to be a free blue hits a free red. The red and the blue exchange their directions, and so that creates the perpendicular release of the red energy, and there's a change in the blue's energy, but it doesn't matter because it didn't impose any momentum on the object. Alright, well, anyway, it's still not tidy enough, so I have to, it's not tidy enough. But look, the simple argument I'm making is there's a mechanism, and the mechanism is simply, the rule is that for however the mechanism works, okay, that when red energy goes into a blue object, when a blue energy goes into a red object, it comes out one of the dimensions. So in, out, one of the four perpendicular dimensions. And the same thing goes for the opposite reaction, which is the proton energy hitting the electron, and you end up with it leaving in one of these perpendicular directions. So that's the simple rule. Now, the fact that I don't have a simple explanation for exactly how the rowers accomplish the task doesn't mean that you can't understand that, oh, it's not that complicated. You just have to have a system that allows the rowers to do something that allows that to happen. All right. So anyway, till the next time and such. I mean, you could say that I mean, theoretically, you could say that it does actually cause a little bit of momentum, this change, this 90-degree change. But the bottom line would be the blue, when it hits a blue, creates a 180-degree exchange. So the bottom line would be is this exchange is twice the energy of this exchange. So mathematically you could understand that even if there was some momentum imposed on the object, the momentum is still half the momentum of the reaction. The exchange that happens for the 180-degree exchange is still twice as much energy, because it's twice as much angular change. So the difference in the momentum is much greater with the blue on blue reaction than the red on blue reaction, and that would still give you the capacity to create a mechanism inside of matter that overcomes drag, because you have one reaction that's twice as strong as the counter reaction, the reaction that's its opposition. Alright, so that should be enough. Alright, so sorry about the bit of sloppiness at the end, but it's physics. You know. It's really hard to do it, you know, on this grammar school level. You know, trying to explain everything, and it's a lot of stuff to explain. But again, only because my theory actually works. The reason why there's a lot for me to explain is because this theory actually works. It has parts that make sense. Again, they don't have to do details because they don't have an ocean. They don't have boats. They don't have rowers. So, well, they don't have to have details.